I want to help you guys out a little bit and do some of these word problems for you. So I'm making a video for you guys to see. So we have our revenue problem, and it says your price is equal to negative 16x plus 100. It's find a model expresses revenue as a function of x. So one of the things you need to know is revenue is equal to price times however many are sold. So it says revenue as a function of x. So for A here, we write R of x is equal to, now I know my price. I have a price function right here. This is going to be negative 1/6 x plus 100 times x. So my revenue function, when I simplify, is going to be negative 1/6 x squared plus 100x. So that is for A. For B, it says what is the domain? Okay, now for B, what you need to remember is your revenue function looks like this. So your domain is going to be this area from here to here. And that's actually where y is going to be equal to 0. So I do a little bit of algebraic solving. I say negative 1/6 x squared plus 100x. When is that equal to 0? Easiest way to do this is you can just factor an x out, and that solves a lot of problems. And so you have either x is equal to 0 or negative 1/6 x plus 100 is equal to 0. The x is equal to 0 would be that point right there. So I know that my domain is going to be from 0 to something. I subtract 100, negative 1/6 x is equal to negative 100. Multiply each side by negative 6, there we go. And so this ends up being x is equal to 600. So my domain is from 0 to 600. Next part of this is going to be what is the revenue of 200 units are sold. So for C, we have, we just plug 200 in. So you're just going to do R of 200 is equal to negative 1/6 times 200 squared plus 100 times 200. And so you put all that in your calculator. Remember, let's just make sure, remember with the calculator, you can do alpha y equals, and a fraction comes up if you want. So we have negative 1/6 times 200 squared plus 100 times 200. And that ends up being $13,333.33. So and how do you know what to round to? You're talking about money, so you're going to round to the nearest hundredth. Okay. Let's go to D. What quantity maximizes revenue? So again, we go back to this right here. Ooh, don't know what just happened there. Which is going to be the vertex of our parabola. So we want to know how many maximize revenue. So we need to find this x value right here, the x value of your parabola. X is equal to negative b over 2a. In this case, b is actually equal to 100 over 2 times negative 1/6, because that's going to be your a values. So I would actually use your fractions. So you have negative 100 over 2 times, and then it's going to be negative 1/6. Press enter. So that ends up being, x is equal to 300. So what quantity was going to be 300. Once you have your X value, how you find your Y values, you plug in, so you find R of 300, and that will tell you what the maximum revenue is. So that's going to be negative 1.6 times 300 squared plus 100 times 300. So okay, and I have, so R of 300 is equal to $15,000. Now we are on to E. It says, what price should the company charge to maximize revenue? Okay, so when it asks for price, we go up here because we're finding P. We do have our X value that maximizes revenue, which is 300. So E is going to be, my price is equal to negative 1.6 times 300 plus 100. Which is going to be, so the price is going to be $50. And so that's how you do one of the revenue problems. Our next one is a maximum area one. You're going to see these in calculus. You're going to see a lot of this stuff in calculus again. So you have a farmer, he has 2,000 meters of fencing, wants to enclose a rectangular plot that borders on a straight highway. If our farmer does not fence the side along the highway, because let's say it already has a fence, because we don't want to kill any of their cows, what's the largest area that can be enclosed? So right here we have our highway. Okay, I always like to label the dimensions. See, I'm going to have two X's and a Y here. I like to have, if I have two sides that are the same when I start with the problem, I like them to be X. It just makes things a little bit easier. So there's two things that I know. I know I have 2,000 meters of fencing, so I know that X plus Y, if I add up all the sides, I only have 2,000 to work with, so it's going to be 2X plus Y is equal to 2,000. The other thing I know is we're looking for the largest area, and area is going to be X times Y. The problem with this is that X can't just be anything in this case because I only have 2,000 meters of fencing. So the other thing I know is I know my Y side, this side right here, is going to be equal to 2,000 meters minus 2 times my X value. I know that my Y is restricted by that. That's the biggest, that's what we have to deal with our dimensions. So I do the same thing here. I replace this Y. So this is going to be A of X because I'm going to turn it into a function of X where I only have X as a variable. Is equal to X times 2,000 minus 2X. So A of X is going to be 2,000 X minus 2X squared. We want to know what the largest area is. If we actually graph this quadratic, I know that I have my X value is going to be my X value and my area is my Y value. And so this is what I need to find. I need to find my Y value. In order to find my Y value, I need to find the X value first. How I find that is negative B over 2A. So in this case, net B is going to be 2,000. So it's going to be 2,000. So it's going to be negative 2,000 over 2 times, and then the coefficient of A is negative 2. It's only the numbers in the front. And so I have negative 2,000 over negative 4, which is going to be 500. So I know this side is 500, this side is 500. I know that they all add to 2,000, so I know that this side, Y, would have to be 2,000. And sometimes I ask for that. But that's not what it's asking for. It's asking for the largest area. So I plug 500 into my area equation. So that's going to be, so the area is going to be 2,000 times 500 minus 2 times 500 squared. so the area is going to be 500,000, and it's actually your units are meters squared. So those are those two. Let's move on to the next couple. Okay. And some of them are just clarifications, but it's the same thing over and over again. Okay, projectiles firing, inclination of 45. I really don't need that. It just has to do with this equation. The muzzle velocity is 100 feet per second. That's where this 100 comes in. The height of the projectile is modeled by this, where the x is the horizontal distance. Okay, so what horizontal distance from the firing point is the height of the projectile a maximum? So again, we have this same thing. We are still finding the vertex of our parabola. So I know it's going to be x is equal to negative b. So in this case, my b value is 1 over 2 times a. A is always whatever is outside the x squared. So this is going to be negative 32 over 100 squared. So my fraction, use your fractions, is going to be negative 1 over 2 times, we got another fraction here, negative, let me just go back, 32 over 100 squared. Press enter. I have 156.25. Okay. So 156.25, and we're talking about feet. Find the maximum height, so we substitute it in, so that's going to be h of 156.25 is equal to negative 32, 156.25 squared over 100 squared plus 156.25. So we put all that in the calculator. So it's going to be and I have 78.125. The last one, I wish I'd left a bit more room for this. So at what horizontal distance from the firing point will the projectile strike the ground? That's when h of x is equal to 0. So I'm going to say 0 is equal to negative 32 over 100 squared x squared plus x. We can just solve this way. So it's x times negative 32, 100 squared x plus 1. And when I factor, x is equal to 0. Negative 32 over 100 squared x plus 1 is equal to 0. Negative 32 over 100 squared x is equal to negative 1. I multiply by 100 squared and I divide by 32. I multiply by 100 squared, divide by negative 32. And I end up with 312.5. So remember, my starting point is 0, 0, and then this is going to be 312.50. Okay. Last one is something we need to, let's just see if I can make this. Okay, is one of these statistics problems. And so you guys just have to know how to put it in the calculator. There is a free app, Calc84, that you can use that'll give you these same calculations so you can practice. So you press Stat, you go to Edit, and you start putting your values in. So we have 1994 through 2002. Okay, and then we have our values. 753, 753. Sorry. 737, 760. Okay, so once you have all of your data in, our big thing here is, I want you guys to see the data, but it's not really something that you will be tested on. So if you want to see your data, you do second stat plot, and then you'd go to plot 1, you'd press on, you'd make sure it's list 1, list 2. You'd want to go to window just to make sure that your viewing window is okay, because right now my viewing window is an issue because it says I only go down to, my X minimum is -10, but my table starts at in the 90s. So I'm just gonna go through and make sure that my window, so I'm gonna go to 2003, my Y minimum, so, or what were we at, 753. Okay, so I worry about my minimum a little bit. Maybe 730 and 910 for my Ys. Okay, and you can go to Y equals, you make sure that plot 1 is on, you press graph, and I can't see anything. So let me just see, because this is, sorry guys. All right, Y equals, okay, well, hopefully it worked on yours. I should see a scatter plot here, but I do not. So that is actually a bit odd. List 1 and list 2. Oh, there we go. There we are. Okay. Oh, there we go. All right, sorry. Okay, I'm done goofing with this. It works better on your calculator. I can get it to work on mine. I'm not sure why it's not working on this one right here, but you guys have the idea. The important part is that you find an equation. So I go to stat. That's the thing that I want you to see is I'm only giving you quadratic. So you go to stat, you go to calc, and you go to quadratic regression. You press enter. Maybe that's my problem. Oh, That's why, because I didn't have my 908 in there. Okay, so there it is. All right, go back, calculate quadratic regression. Do you see that says the length of the list must be equal to, I just didn't put those values in. So I go back here, I look at my screen, it says ax squared plus bx plus c. It gives me 8 is 4.30. So when I write my equation, it's going to write it as, so for A, it's going to be y is equal to 4.30 x squared. And then I go to my B value, which is negative 17,176.01 x. And my last one is 171,407. 14.06. Okay, and the principle is then I use this equation to answer the rest of the problems. So I'm going to go to D, in which we're the least cosmetologists and hairdressers, where they're the least number of cosmetologists and hairdressers. So for D, that's going to be your X is equal to negative 17176.01 over 2 times 4.30. And so I get 1997. And then how many were there in that year? So then we plug 1997 into 4.30 times 1997 squared minus 17176.01 times 1997 plus 171,407.14.06. And for some reason, I get negative 11,339.21. So apparently, back in 1997, we were short quite a few hairdressers. And I'm not exactly sure what went wrong there. Use the model to predict the number of hairdressers in 2020. You would just plug in for X into the equation. You'd plug in 2020. And I got negative 9,106.14. So I'm not sure what went terribly wrong with this equation, because I don't know if it's just the rounding was an issue, because sometimes that is. I wouldn't worry about it too much. What I'm looking for is what you guys your understanding of what to plug in where. The one that I have on the test does not come out so weird. I didn't mean for this to come out weird, but I wanted to discuss all the strange answers that you get that didn't make any sense. Hopefully that was helpful. Come in with questions.